Welcome back, everybody. Now we're going to start in with continuous variables. So we have continuous quantitative data that we're going to work with. Now when we had categorical data and we had discrete quantitative data, we had obvious categories to work with. For example, we could talk about color or the blood when we were doing the phlebotomist example. And then when we were doing the Wendy's example, we talked about 1, 2, 3, all the way up to 11 customers coming in at a certain span of time. So we could have obvious categories. However, with continuous variables, they're not obvious because we have a continuous spectrum of numbers that we could have. So we are going to create our own categories. So we're going to create what we call classes or bins in which to work with. So we look here, and we can create these classes. Sometimes you'll see them called bins, and they're the way that we're going to define our quote-unquote categories. So the continuous data is grouped into certain categories. So what we're going to find out is that not all histograms have to look exactly alike for the same data, because how people group them together could be different. Now there are ways where I could say I want you to have so many classes, and I want these things called cut points to be whole numbers. That would kind of force everybody's histogram to look similar. But in reality, there could be many different histograms that would come out from the same data. So what we're going to do is we're going to replace our categories or our individual values that we have in our discrete data with these categories, with these intervals of numbers for the continuous variable. And we're also going to find out if our discrete variable, if we have a lot of them, lot of different values, sometimes we'll have to group those into classes, and we'll see an example of that in the PowerPoints. So we're looking here at a place where we have discrete data, age, if we want to consider that discrete, but there are so many different classes, or so many different numbers, that we have to put them into classes. And that's a great way to segue into looking at a continuous variable. So if you can see in that first class, 20 to 29, that's a class. We put all the numbers from age 20 to 29 in one class. So a person that's age 23 would go into this class. A person age 45 would go into the third class. So we could then group them together, and the heights of our bars would be how many people were in that certain age group or class that we created. Now, when you look at this, the numbers to the left, those are our lower class limits. The numbers on the right-hand side on all these different groups or classes or bins are our upper class limit. But you'll notice here on the very last one we have an open class, an open-ended class. So 60 and older, because it would be, I don't want to just do 60 to 69, 70 to 79, because there might not be that many people. I have this open-ended class. And I could also have an open-ended class on for my very first class. And those classes, again, because there's such a large span but not enough people in them for it to be worth to make other classes. So we have these open-ended classes. Now the next very important feature is class width, to say how big is my class, what is the width of my class. Well, that's very important because we always want to make the widths the same when we're dealing with our data. So how do I find out the class width? Don't take the upper class limit minus the lower class limit. That would be wrong. You take two consecutive lower class limits and subtract the two to find out the class width. Now you could also take the two consecutive upper class limits to find it, but I'll use as my convention always looking at the lower class limits to find the class width and this thing called a midpoint. So to find my class width, I would take, we had 20 to 29, 30 to 39. Well, the two lower class limits are 30 and 20. I subtract the two, so the class width is 10. Now, if I want to find something called the class midpoint, again, I take the two lower class limits, the sum of the two consecutive lower class limits, add them and divide by 2, and you'll find the midpoint of the particular class that you're looking at. So for example, because I didn't say that very clearly, let's say that you're doing 20 to 29, 30 to 39. I want to find the midpoint of 20 to 29. You would take 20 and the next class up from it and take its lower class limit, 30, add those two together and divide by 2. So my midpoint would be 25. So let's say that I had a sample of 3,373 subjects, and I looked at their ages and I put them into these categories or classes that we made. And down below on this PowerPoint is a summary of that data. This is called a frequency table. And what we see that we can put, we have our different classes, we know what our class width is, and with that will determine what our class limits are. And then we can do our counts, and that's how we make our frequency table. And from the frequency table, we can do a relative frequency table, and once we have that, we can then start making our histogram. Before we move into making histograms, let's look at this frequency table, and let's look at good practices for constructing the table. There's no unique or best way to select classes, but the classes there should be no overlap. A piece of data can only go into only one class, so we can't have any overlaps, nor can we have any gaps. You don't want your data not to have a place to go, so we got to make sure that there are no overlaps, no gaps. We want all our classes to have the same width except for the possibility of those open-ended classes, and that could only be our first or last class, remember. And then, of course, our classes need to cover the range of our data, so every data point has only one place to go. The lower class limit should be a reasonable number, and the class width also should be reasonable. You don't want something so huge it collects all the data, or so small that you have to have 100 bins or 100 classes. So yeah, you typically want to use between 5 and 20 is a good number. More than 20, you get too many bars that you're looking at. Less than 5, it doesn't give you good information. Remember, if you have too few classes, your data is going to be bunched up. If you have too many classes, it's too hard to see any type of pattern that might be going on. So there's some finesse that goes on with making these classes and then eventually making a histogram to go with the frequency table. Let's look at a histogram, which is just a picture of a relative frequency or a frequency table for quantitative data. So we're going to construct this table, then we're going to place the variables that we're interested in on the horizontal axis, and then we'll count how many go into each of the categories, and that will create our bars for our histogram. So the rectangle above each of the intervals will tell the frequency, how many, or the relative frequency in each of the classes. So what you should remember when you're constructing a histogram: first of all, plot and label only the lower class limits. We call those cut points, so we want the cut points only to be the lower class limit of each of the classes. So if we look back on the slide above this one, when you see 0, 0 is the lower class limit of that first rectangle. 2 is the lower class limit of the second rectangle. So the data value 2 does not go into this first class. The value of 2 would go into the second class. The value of 4 would go into the third class, and so forth. So you only want to plot the lower class limits for each of your classes. Give a good descriptive title, very important, because what you want is when that graph is displayed that you have to say very little about it, that someone could look at your graph and have a wealth of information from there. So a very good descriptive title is most important. And in our class, we're going to use the format, and it's a good format to use, is say the distribution of, and give the variable name for, and describe the items. Now, label that horizontal axis, those variables of yours, and definitely put in the units if there are units involved. Very important that people know that. And label the vertical axis. Is this a frequency or is this a relative frequency histogram? These are the type of good practices that you're going to need. Now what we're going to do in the next segment, my next installment is we're actually going to create a histogram using